Test earth leakage by ELCB and relay. Hello, this is Charumati. Today, let's learn about testing earth leakage by ELCB and relay. In this chapter, we will also study how to identify the terminals of ELCB, earth leakage circuit breaker, by connecting the ELCB in a power circuit and test its functioning. Finally, measure the leakage current at which ELCB trips off.
Required tools: combination pliers 150 mm, 1 number; screwdriver 150 mm, 1 number; electrician's knife 100 mm, 1 number; wire stripper 150 mm, 1 number; ammeter moving iron type 0 to 10 amps, 1 number; ammeter moving iron type 0 to 100 milliamps, 1 number; Phillips star screwdriver 100 mm, 1 number. An earth leakage circuit breaker (ELCB) is a safety device used in electrical installations with high earth impedance to prevent shock. It detects small stray voltages on the metal enclosures of electrical equipment and interrupts the circuit if the voltage level exceeds danger threshold. It works by detecting an imbalance in the current flowing through the live and neutral conductors. An ELCB is a specialized type of latching relay that has a building's incoming mains power connected through its switching contacts so that the ELCB disconnects the power in an earth leakage, unsafe condition. The working principle of voltage ELCB is quite simple. One terminal of the relay coil is connected to the metal body of the equipment to be protected against earth leakage, and another terminal is connected to the earth directly. The ELCB contains a current transformer that detects the difference in current between the live and neutral conductors. If there is no current leakage, the current in both conductors should be equal and the ELCB does not trip. The ELCB detects fault currents from live, hot to the earth, ground wire. Within the installation it protects. If high voltage appears across the ELCB's sense coil, it will switch off the power and remain off until manually reset. Thus, protecting the electrical system in the building. However, if there is a leakage current to earth, it will cause an imbalance in the current, and the ELCB will detect this imbalance and trip, cutting off the power supply to the circuit. This action of tripping the circuit is necessary to prevent electric shocks or electrical fires from happening. The testing is crucial for human life, which prevents any electrical shocks, fires, and hazards. Let's start the experiment. Task 1. Identify the terminals of ELCB. Collect the ELCB from your instructor and read the specification given on it. Note: identify the supply terminals and load terminals referring the marking on the unit as given in Figure 1. Task 2. Connect and test the operation of ELCB. Wire up the circuit as shown in the circuit diagram, Figure 2. Switch on the main supply, keeping the MCB and ELCB in on position. Close switch S1 and operate the water rheostat till the ammeter A reads about 5 amps current. Note: keep variable resistance in full cut in position. Press the test switch and vary the variable resistance and note the leakage current and record. Record the leakage current at which the ELCB trips off. Open the external test switch and reset the ELCB. Test ELCB for trip function by operating the test button. In this case, the ELCB must trip off when the button is pressed.
Recap. Identify the terminals of ELCB, connecting the ELCB in a power circuit and testing its functioning. Measure the leakage current at which ELCB trips off. Thus, we have learned how to test earth leakage by ELCB and relay. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Thank you.